So, hello everybody. I really hope you enjoyed the conference so far. I'm Axel. I'm together with my colleague Augusto responsible for smartextract. And in this talk, we're going to show you how we apply large language models to reliably extract information from complex business documents and what it actually takes to make that work in practice. Here's what we cover first. I give a quick overview of smartextract, and then we're looking into the potentials of LLM visions, then into the combining OCR and LLMs to extract complex tables in data extraction, and then of course we also have LLM benchmarking. So let's start with the basic. What is smartextract? Smartextract is an AI assistant that understands business documents in emails like a person, just faster and without the fatigue. It's basically built to extract information from complex business documents in emails, to take that extracted information and match it across documents or other IT systems like ERP systems, to transfer verified data to a downstream system, like it could be an ERP system or a Google Sheet. And if it's necessary, it also classifies documents by type with high accuracy. smartextract is already in use in various industries and departments, but let me give you two examples. For example, an energy consulting and software company is using smartextract to extract key data from energy certificates in order to then downstream it to their software product. And then what you see here is the purchasing teams. They are also using smartextract as an end-to-end product. They automatically extract key data from order confirmations and then match them with invoices and then transfer that verified data into an ERP system. These are just two examples we basically show, but what it gives you an idea of how flexible smartextract can be used. You can either use it in your own product, for example, just with the extraction component, or you can use it end-to-end, like the purchasing teams do it, and you use it by extracting information, matching it against the extraction, and then transfer it. Before I hand over to Augusto, going into the technical deep dive, I would really like you to get a feel and look how smartextract actually looks in action. You have already seen two examples what can be done, but I would really like to give you an actual product insight and practice. And the reason for that is also I'm going to show you a document that is Augusto later on also showing in its technical deep dive, so you get an idea. A two-sided insight. One, you get the view from a customer, but you also get a look behind the curtain when Augusto explains the document. Let me quickly start the product. So what you see here is our main interface. And what you see on the left-hand side, I'm going to use that pointer because what you see here are basically inboxes. That's how we call it. And each inbox is connected to one AI template. That means this is, for example, connected to an AI template that extracts retail invoices. And this, again, is connected to another AI template. But if you usually sign up for the first time, it would look completely different. It would look like this. What you basically can do, if you visit smartextract AI, you can sign up for free. And then what you see here is a library of free AI templates that we have pre-built. For example, you could choose a purchase order. Let's quickly do this. Let's create the inbox. So that's what I mean. So now you see the inbox, and it's connected to that order AI template. So you can now have three options. You can either forward via email, you can ingest it via API, or you simply upload it manually. Let's actually do this as an example. So what we can see here now, it starts extracting and trying to find the information. But let's, in the meanwhile, as we see it's processing, look actually at the document that is really relevant also when you listen to Augusto's part. There's a retail document. And if you go into it, what you can see here on the left-hand side are the previews of the single pages. In the middle, you see the actual selected page. And let's scroll in. So, for example, and on the right-hand side, for some reason, there's... Yeah, we blacked it out, exactly. This is the information we blacked out. This is why it's not there. And what I would like to show you is actually that information, because this is what Augusto is also focusing on. Let's scroll in. This is a quite complex table, because what you can see here is different shoe sizes. And each shoe size, again, has like some blank areas, and it also has some numbers down here. And these numbers show how many orders of these shoe size has been ordered. And if you see this one, you can find the article number that was extracted. You can see the description of what kind of article was ordered. And here you see the different sizes, 4, 4 minus, 5, 5 minus, 6, 7, 8, and so on, and the different numbers associated with that order. And exactly, so this gives you a good idea what we're extracting and what Augusto is going to speak about. In the meanwhile, I think this might have already, depending on exactly, is completed already. And here what you can see now is everything that is bordered here has been extracted. And this is our standard template. And now what you could see, I can do this live. Let's see how much time I've got left. Do you have a number? No. Okay, I'm not going to do it. Otherwise, I would have shown you how to customize it. But no problem. I'm going to show that to you if you're interested in after the presentation. Let's go back to the presentation. So now we have an idea about use cases. You have seen how the product works. And now I would hand over to Augusto for the technical deep dive.
Okay, how it works. Okay, so LLM vision. So in essence, LLMs are text processing tools, right? You ask some question and you get an answer, both in form of text. A reasonably new feature in this area then is LLMs that can also understand images. And the way it works is that you supply some question as text and then you can include some images. The way they get processed is actually the image is broken up into small patches, and each patch is encoded like a token, and then the LLM just generates text based on this input. So in terms of architecture, it's very much the same model. But this is a feature now we have available, and let's see what we can do with it. This is something that we did for a user, right? They had these forms that with some checkboxes which were filled in by hand. And then you can just send a picture and ask which checkboxes are selected. And if you just ask this question, then probably what you would get from this example is that, okay, menu 3 is checked here. And in this case, the model would likely also tell you that this item is checked because there is some blob of ink in there. But I think we probably can guess that this looks more like it was someone changed their mind and they blacked out their choice. So if we include this explanation in the prompt, just say don't include boxes that are blacked out, then actually the LLM, I use Gemini for this one, by the way, so the LLM actually understands it, and then we get the answer that we expected. So this is really cool, very useful, easy to implement. So for comparison, if we use a commercial OCR tool, this was AWS. So somehow it's correctly understood that this item was not checked, but then it also thought this X was a little too messy and didn't include it in its extraction. Okay? And then if you try some other OCR, then it will find this X, but also find that X. Okay? And I'm not saying this to criticize any of these OCRs. They are very reliable and robust, but they are just not as easy to adjust to special use cases. Okay? So they do what they do it very well, but in this case, they don't do what we need. So then this is why I think it's such a cool feature now, LLM vision. So then maybe the question comes up, do we even need OCR anymore, right? Can we just not replace OCR by vision? And maybe, I think the answer at this point is, in some cases, certainly, probably not all. So some good things about LLM vision, and I say potential because I think this is such a new feature that it may change and improve much more, but it can be cheaper and faster than traditional OCR. Just these two previous slides cost me, actually, OCR can be quite expensive. Those 2 slides cost me 12 cents to make. So when you have a lot of slides to prepare, it can add up and become expensive. So LLM vision is also much easier to customize, but it has some drawbacks also. They don't provide geometry information. With normal OCR, you know exactly where your bounding boxes are for each word, not with LLMs. And on very dense pages with a lot of text, then the LLM could get overwhelmed. So actually, I was quite skeptical, and I asked Gemini again to just read this entire newspaper page, and I was actually surprised. It basically read everything. It was very good at understanding the order of these columns of text, which can be a bit confusing, right? So say from here you have to go there, but from here, I guess this is the end, right? You don't go there. It's not as simple. You have to learn to read the newspaper. Yeah, so what I got out of Gemini was, I would say, very good, except that it decided to skip certain elements, like the image captions were not there. This thing at the top that looks more like an ad wasn't there. So maybe those are not even so important things, but it also decided to skip the date of the paper. So I don't know. You get what you get. It can work, may not work. You have to try, but it's a very interesting and useful feature. Okay, so then now I'm going to change topics a little bit and discuss then information extraction from this complex documents, these tables that Axel showed in our demo before. So just now to say something very general, when I say information extraction, what do I mean? I mean this idea of taking in as input a free-form document made for humans to understand, and then feed it to some computer system that converts it to structured data. So I'm representing this by this little JSON thing with some prescribed schema, right? Some field names. So this is what information extraction is. It's a very large field of research and application. There's a bunch of methods. These methods generally work, but there's always this very long tail of strange documents, edge cases, difficult things. So this makes this a little complicated, right? So, and now we're also using this terminology here, complex documents. So what do I mean by that? So let me start with a non-example. A non-example to me would be cashier receipts like this one. And I mention it because it's a very common benchmark in this information extraction field. But these documents are not really that interesting or complicated to understand. So this one model from 2020 already claimed 97.7% score on this particular benchmark data set. So it is, you could say this is solved. Now, something more interesting, which is what I want to look at today, are some industry-specific documents, and what I want to pick today is this invoices from clothing retail sector, right? So this is some order some store made. So they got 64 pairs of this shoe, but then the interesting thing is you get some items that were ordered, but then each item has some variations, sizes or colors, right? And this is expressed by a little table within a table. So this is what makes this particular type of documents hard to manipulate and read and understand for the machine. So, yeah. So now let's see, right? How can we deal with those things? So the more direct approach, so if we're discussing information extraction via LLMs, the first idea you have is to combine OCR and LLMs, right? So what you would do is you would start with your document, and here I'm just focusing on the complicated part, which is the line items, right? The whole document would include some header information also, but fine. So what you do next, you take your document and you feed it to an OCR tool, and then it tells you where each word is and what the bounding box is, and then you convert this to some linear plain text, right? So I converted my document to plain text, and then I was careful here to put the little table within a table to express it as this array of numbers which are aligned as in the document. Okay, so this can be done, and now that I have pure plain text, I can feed it into an LLM, right? So I'm gonna erase this picture and move this to the side. Oh no, I have the whole thing. So picture, OCR, and then I sent this text to the LLM with a prompt saying what I want, and then I get some response, which is, in this case, it was what I want. Okay, so there's a lot of text in this slide, but it doesn't really matter. It's just an idea of what the steps are, right? So the final answer is some structured data, and these numbers do match. So this is fine. This is when everything works, this is what we expect or what we would get. Now let's look at this long tail of complicated situations, right? And yeah, so this is exactly the document Axel showed us before. So again, right, so 1 minus 2 minus, somehow these are shoe sizes. I don't know how exactly, but fine. And then these ones here below mean that we ordered 1 pair of each of these things, right? This is the information we want to extract. So let's do our first step, which is to feed this to a OCR tool and then convert to plain text. And this is what I got. So somehow, in this case, okay, these ones are misaligned, and it was not our fault. It was really the OCR who somehow decided that this string of ones form a single word, okay? And I can only speculate why this happens, but I believe it's because since there's this longer gap between ones here, it decides that the spacing between words in this line should be roughly this size, and then these ones are closer together, so they're probably one single word. Okay, so the OCR did this. It's one of these very good and reliable commercial OCRs. Probably did it because, on average, it's a good decision. So it is what you get. So in this case, we already tripped into a problem here, and this document, we're not going to succeed extracting in this with this approach. So this is bad. It is annoying, and it is what it is. So let's look at a second example. And so again, right, so here 3 products were purchased, and then there's the table of sizes. Okay. So what is interesting about this one is that this table has a lot of gaps, and this is what complicates our life a little bit. But let's see what happens. So first step, I feed to the OCR. The output looks reasonable. It made some mistakes for these half numbers. It sometimes made a %, sometimes it made 41 space a half. Sometimes it put things together, which now is a bit ambiguous what this means, right? 361/2 was supposed to be 36.5. But fine, we get a reasonable output from the OCR, and now we can feed this to an LLM, right? So again, this is my plain text version of the document. I feed to an LLM asking what the sizes are, and this is what happened. Oops. So we have this string of shoe sizes. This the LLM understood correctly. So it even fixed the OCR mistakes. But now come the row of numbers below, which are the quantities. And here it actually understood the quantities, but it just cannot align each number correctly with the size it refers to, right? So the 38 was supposed to be 2. So this is just wrong, okay? And yeah, so this is what happened. So also didn't work. So to summarize what we've seen concerning this text-only approach, right? So even robust and well-tuned OCRs can struggle reading some documents, and this is by their nature probably hard to fix. Even the best LLMs have limited ability to understand the layout of the text. So formatting text with white spaces to more or less make it look like the original page. It actually helps, but helps only a little bit. And understanding precise column alignment is not, the LLMs just cannot do it at this point. Just like they cannot count characters in a word, this kind of tasks that are very hard for LLMs. So it just doesn't work, maybe not yet. And then an idea is that maybe feeding the LLM not plain text, but some text with more complex markup could help, right? So if you feed a full HTML document with like table tags and formatting, this adds too much noise and it does not work. But maybe some more lightweight kind of formatting could work, right? But I think it's not a solution in our case. I think you would need to have a specially trained LLM to make this work. But it's a potential direction. Okay, so now let's have a look at then using vision to deal with the same problem, right? So the idea here would be, instead of doing this two-step process that we saw before, first converting a document to plain text using OCR, and then converting plain text to structured data using the LLM, we could attempt to let the LLM do the task end-to-end. So the input to the LLM would be some prompt and then an image of the document, not the plain text, but just the image of the page. And then the expected output is directly the structured data that we want. So let's see if this works. Okay, maybe it does work. Okay, so if you try this good case I showed you right in the beginning of the discussion, the LLM understands those tables, it's fine, it can extract the data. So it is a quite viable approach. But now when we start looking again at those complicated edge cases, right? So this is the bad document I showed you just now. So if you have a prompt saying, oh, convert this to JSON structured information and send the image, then you get an output that is really, this is bad. So this is, okay, the sizes were read correctly, but even this 1, 2, 3, 2, 1, even this string of numbers is incorrect. Here the model really hallucinated some extra stuff that makes no sense. So this didn't work. Maybe you can now try to do prompt engineering, be very specific, say what, like there is holes in the table, please consider that that's a 0. Also doesn't really help, or it didn't help in this case. Who knows, right? What happens in another use case, but for this one, it was our experience. The third thing you try then, when you're in this situation, you try to add examples to the prompt, right? So you can add also some little tables and the expected extraction in the prompt, and then you give the document you want to extract, and you hope something good comes out of it, also didn't happen for us. So let me show you now the one thing that actually helped us and worked in this case. It was the prompt, the instruction really, the simplest instruction was fine, but we had to, if we just provide one line item at a time, so instead of an entire page of the document, one single line item, then the LLM actually manages. So it manages to focus on what matters and extracts the size table correctly. Okay, so this is the way we managed to address this problem. So to summarize then, can we let the LLM do extraction end to end? Yes, it definitely works on simpler documents. For more complex documents, the model gets overwhelmed, and then inputting just part of the document helps. And this means, of course, that you need some other way to chunk the document into reasonable, smaller chunks, which probably will be some other type of vision model that you have to train. But it can be done. And then something else I didn't mention before, but sometimes supplying both the image and the OCR text, so 2 times the same information in different formats, this sometimes also helps the LLM. It's an idea you could maybe apply in some cases. Okay, so this is what I had to say about this one, this tables within tables. And then I wanted to, in the last minute, do something a bit unrelated, which is just compare a few different LLMs and a few different adaptation techniques. So the point here is that now there's plenty of different LLMs to choose from, right? There is like the large commercial ones like GPT and Claude Sonnet. Then I think more recently we had these smaller versions of those models appearing, right? So GPT Mini would be one, Gemini Flash also, right? So they're just smaller and cheaper to run and not as good, but good for many things. And then finally, there is now a slew of open source models, or maybe we should really say open weights, because you get the weights, you can run those models, you really don't have a recipe to construct the weights. But yeah, so those could be deployed locally. They can be trained as you need. They offer some advantages in some cases. So we have all these options, and then we also have a lot of techniques to actually implement some application using LLMs, right? So the most basic and the first thing you always try is to do prompt engineering, right? Try to explain well to the model what you want to do. When you want to improve on that, then maybe the next thing you can try is to add some examples to the prompt, like I actually showed before, this idea. To sound fancy, we could refer to this as in-context learning, right? And then the third option is to actually adjust the model weights using training data, like those who are for more than a couple of years in the field know this is what we always used to do, right? Have training data, fine-tune a model. So, okay, so what I wanted to see here is how these different combinations compare. Yeah? So let me explain what our benchmark. In 1 minute, I'm going to show you some numbers, some performance metrics, right? So just want to tell you what the problem was. So the problem was to extract data from some invoices from one of our users. And these are like, again, these commercial invoices that have a lot of little details and different vendors with different formatting. And we ask reasonably detailed information about the header and the line items. Okay, so it's quite a complete dense extraction. Not a very simple problem. And the metric, okay, I don't want to talk too much about it. The metric is just some average of Levenstein distances between the ground truth and the extracted data. it's some numbers that are meaningful when you want to compare one experiment with the next. What the numbers mean in absolute terms, I would say not much. I think we shouldn't even worry too much about it here. And then finally, when I talk about fine-tuning, I just want to say up front how it was done. So we took 100 documents from our user, which we labeled, and then threw in together with that a bunch of benchmark data. So some of these standard benchmark data sets you get online, you can download. You have ground truth, and yeah, so we can just throw that in together. And then we used, of course, this low rank adaptation techniques where you're not training the full model, but just a small fraction of the weights. And in the case of the commercial ones, of course, we use the vendor's API. Okay, so now let me show you some numbers and see what we learned. So I have 4 different fine-tuning techniques and 4 different models that I'm comparing. So I'm comparing Qwen 4B, which is one of those open weights models. Then I'm looking at 2 of the small commercial ones, Gemini Flash and GPT-4o Mini. And then finally, one of the big LLMs, maybe that you're more familiar with even from using in day-to-day work. So, and the first experiment, I labeled it as plain. I could have labeled it as zero-shot learning because the model learns to do a text based off of 0 examples. It's just prompt engineering, right? So we just describe what we want and in some detail fit the document, see what comes out. The easiest thing you can do. And this is what the result, right? So you see that, okay, of course, the big commercial model did best. If you go down to the mini version, it's much cheaper and faster, and you lose some performance. Not a lot, actually. Gemini did quite poorly, and the reason wasn't even that it didn't understand the document, it just struggled to format the answer exactly in the shape that we expect. But of course, when you're doing automated information extraction, this is very important, right? That we get exactly the format we expect. And then the open source model, it's reasonably small, and it did quite well, I would say, compared even with the GPT Mini. Okay, so this is one thing. So how can we try to improve it? By adding examples in the prompt. In this case, we added just one example, so the model is learning a task off of one example, one-shot learning. And this is how things changed. So everybody improved. Some improved more than the others. The gap between these 3 cases really closed quite a bit when you just had one example. Then third thing you can try is fine-tuning. And this is what we get then. Okay. Then again, so using the GPT Mini or the big one, really same performance, no difference. Gemini finally learned the data format we were expecting, and it's also competitive, and yeah, Qwen also improved a bit more than by using examples. And then you could try to combine both things, fine-tuning and examples. Maybe this is the best, but the answer is that it doesn't really help. Sometimes it's even, like in this case, right, you get the worst of both by combining. So unfortunately, this doesn't bring anything new. Okay, yeah, so this was the result of our little informal experiments. And then to wrap up, I just wanted to show something, just a related idea. And it comes from a blog post I really enjoyed reading. I think it's a nice read. I recommend it. And they address exactly this point I was talking about and more about prompting and these kinds of things. So I think it's interesting. Just see, someone else found some related results. And yeah, the conclusion from this one is that clearly fine-tuning was not the best option. So I'm going to get there. But let me explain what this is. This is about having an LLM play chess. Okay? And what's happening here is in these graphs, you're getting some LLM. So say this curve is for GPT-4o, right? you have the LLM playing chess against a chess engine. It doesn't play very well, so the chess engine is set to a not very high level, but okay, you can make these two different machines play, and in chess, okay, everybody starts at the same situation, right? So the game is in a draw, and you can kind of measure how far you're from winning or losing. So as the game progresses, each player takes its turn, and then one gets closer to winning or losing, right? And so this is what happened. So each LLM playing against the same chess engine, right? So GPT-4o mini starts to lose very quickly. GPT-4o starts maybe seeming like it could win, and then it starts to lose. This is what happens. And now, this was just plain prompting, right? And now comes the second experiment. You add examples in the prompt. And so GPT mini jumps from this green line to this purple one, and 4o from the yellow to the blue. So they benefit a lot from some examples also. Now we can try fine-tuning. So how does that compare? And this is the curve for fine-tuning. Okay. So just so you can read the graph, so the green and the yellowish line, they are the same as before, and I'm just replacing the trial with examples in the prompt with a trial with fine-tuning. You can fine-tune because you can find historical games online, right? And you have a lot of training data, actually. So I'm just going to switch back and forth between the slides so you can see. So you see, the GPT mini actually does better with fine-tuning than with examples, but GPT-4o actually does much better if you just give examples as opposed to going the trouble of fine-tuning. And then if you combine examples and fine-tuning, they also find the same, that it's just doesn't really help. It's as bad as fine-tuning, as bad as good. Yeah, okay, so this was maybe a little aside because I thought it was fun and kind of aligned with the results we got in our experiments. So then, this is my last slide, just to summarize. Optimizing an LLM task is an art. There is no rules here that always work, and it can be hard, right? So LLMs can do a very good job at information extraction, but you have to try and employ the right techniques, right? And need to have a little arsenal of tricks that addresses this long tail of edge cases, difficult documents, strange things that crop up all the time. And LLM vision is a powerful feature for information extraction. And the second point I want to bring is that in-context learning, which is the fancy name for examples in the prompt, this is really helpful. Okay, this is always something that is worth trying. Fine-tuning a model with data can improve the accuracy, but it is expensive, it requires labeling, it's much more work than this simple idea of examples in the prompt. Yeah, so I think that's all I had to say. So I will hand back to Axel to wrap up.
Thank you very much for actually sharing Thank you very much for sharing all the complexities actually we deal with every day in order to solve customer use cases. Sometimes nobody can imagine how complex it can be. So that's why I would say maybe as a conclusion, or what do we take away from home to home? LLMs are powerful, but making data extraction reliable is actually much harder than it looks like. You cannot just plug in an LLM and expect it to work flawlessly out of the box. Optimization is really hard, especially if you talk about complex documents, right? It's almost an art to do it correctly. And yeah, if you summarize all this up, this is exactly the reason why we have purpose-built tools like smartextract for data extraction and matching, because this is where you kind of solve exactly those kind of problems. Thank you very much for listening, and if you have questions, please ask, and otherwise we see each other at lunch.
Yeah, thank you also from my side. Let's have a quick Q&A before the lunch break.
Thank you for the presentation. I'm just curious if once you realize that it's easier for the LLM to look only at one product at a time, did you try experimenting with prompt engineering where you instruct the LLM to first section into products and then only create? Like, I wonder if it would have the same result than if you adapt the prompt like that.
Yeah, I did some experiments and this didn't work. So what I did was to first try to get just the line items, just say the article IDs, and then in a second prompt feed the full page, but ask, oh, just for this one article ID, please give me the shoe sizes. But that didn't help. So.
Okay. And maybe a follow-up, did you try with an agent?
No.
Thanks for the presentation. I was really interested, so I had to drop off the workshop on LLM serving to join the presentation, because we do work a lot also on similar cases, mostly in order creation automation. And the main issue is, like, I'm having a new potential customer now, and they're like, hey, is it going to work? I always have to look into their orders, or rather the orders of their customers, right? Because sometimes it's a complete mess. And the system, the prompt and the validation maybe, and we often use also classifier before that, it just breaks down, like, because the new customer and their customers, they just send a bunch of very different templates, and while LLMs are quite flexible with templates, and on the website you say layout does not matter, to my experience it does matter. So how do you tackle that? How do you make a scalable solution? Do you still have a need to custom software develop or prompt engineer for every customer? Do you use some sort of meta prompting adaptation, like you read out and you prompt your system prompt into oblivion? Yeah, would be interested in that.
Right. So, like you've seen in the demo, we have some standard templates that you can choose from, and those templates, of course, they include in the end gets translated to a prompt. And so these generic prompts, they are a starting point that is good enough. And then we have, for users that come to us where they have more specific needs and we do a little project for them, then we have someone who does some prompt engineering and tries to optimize for their documents. But when it comes to the layouts, our experience is that really this is not the main problem anymore for us. Also because when you do like zero-shot, one-shot learning, the model didn't really learn about any layout at all, right? So you shouldn't even expect that.
What I mean rather is that often we have to specify additional, maybe not the layout in terms of geometry, but layout in terms of logic, right?
Okay.
Sometimes, like often you have Artikelnummer oder Referenznummer, something like that, but sometimes people say it's Hersteller irgendwas something.
Right.
And models gets confused because we
You're
use those in the JSON data object.
Yeah, I think you just got a very good example of the kind of prompt engineering that we do. Sometimes it is to just
additionally then.
Yeah.
Okay.
So one example is just see what ways the article ID is referred to typically in our user's document, and then we add that to the prompt. So yeah, in that sense, sometimes it matters. Yes, you can always improve by prompt engineering, and it's necessary.
Hi, thanks for the presentation. So smartextract helps in kind of like, or avoids manually typing or extracting data. Do you ever compare to human performance in terms of accuracy? If yes, how do you go about getting that data? And if no, how do you know when to stop tweaking and improving?
Yeah, that's a very interesting question. We looked up and we found some research on that topic, right? And, well, I can't quote any numbers, but manual data entry actually also has mistakes, right? Mistakes happen when people work, and accuracy is not 99%, maybe it's 95, I don't know, like in the ballpark of. And yeah, that's an interesting.
So we haven't done it ourselves, like we haven't measured it because it's quite complex, as you say, to measure. So what we rely on is there's research data, which is hard to find, but there's research data out there where people checked out, so how many errors do you do over a period of time, like 5 hours of data entry and so on. And it drops actually quite dramatically. I also don't have one number out of my head right here, but I think it really drops down to 86% accuracy over a period of time. And speed, we have a hand raising, maybe somebody knows more, but we know from customer conversations that deploying that solution helps them save time by really, like, it's a felt, right? They feel the difference, but we don't have hard facts at the moment. That's right.
Yeah, maybe I can back up these 86%. It's something we observed as well. But I think it's not the number to compare with, because we have a fundamental difference in the process. Because when a human does a data entry, very often he gets a direct feedback from the system what is expected. Like if you add something in an ERP system and there's a value which is important, he's forced to write that. And people or humans get very creative in just making the process run through, which you can't do if you automate it. And we often observe that the data quality in the end is much worse, because people think, okay, nobody cares about this value, but the system forces me to write it, and so I write a wrong value. It's not existent, and this doesn't happen, or you have to account for that when automating data entry.
Yeah, that's a good point, because it matches with the feedback we also get from customer conversations, that people just start filling something out, and if they get tired, they just, they don't care because it's so mundane, right? Is it the right word, mundane? Boring, at least, yeah.
I have another question, if I may. You went over the markdown format as an intermediate between the text only and the vision entry. Was that intentional, or did you check, or did you check out maybe services like Unstruct, LLM Whisperer, which exactly do this kind of work as to be able to feed these markdown format into LLM, because that was our best approach to get the most out of similar problems.
Yeah, we didn't use that particular service. We tried feeding Markdown, and it didn't work for us. And probably it's this issue with the sparse tables, with the missing entries. Yeah, I think this is the particularity here that makes it complicated.
Okay, while I'm sure there are many more questions, I would say it's lunchtime. So thank you once again.